Okay, so imagine this. You're looking up at the night sky, all those stars and galaxies, and you think you're seeing it all.
Right.
But what if you're only seeing a tiny fraction of what's actually out there? What if most of the universe is invisible?
It's a pretty wild thought, isn't it? And that's exactly what we're talking about today. Dark matter.
This stuff that we can't see, can't touch, but it seems to be holding the entire universe together.
Yeah. It's like the cosmic glue that we never knew existed until, well, relatively recently.
And that's what we're going to deep dive into today, this whole mystery of dark matter.
Where did this idea even come from? How do we know it's there if we can't see it? And what could it possibly be made of?
And the even bigger question, could it be more than just some inert substance? Could it be, well, something else entirely?
We're going to explore all of that and more, drawing on some really fascinating research and even some pretty out there theories.
So strap in, because we're going deep into the cosmic unknown.
All right, let's start with the basics. How do we even figure out that something like dark matter might exist?
Yeah, because it's not like we can just look up and see it.
Exactly. The story begins back in the 1930s with an astronomer named Fritz Zwicky.
Zwicky, okay.
He was studying a group of galaxies, and he noticed something really strange. The galaxies were moving way faster than they should have been based on the amount of matter he could see.
So too fast for gravity to hold them together, basically.
Right. It was as if there was some unseen mass out there exerting a huge gravitational pull.
Like a hidden hand guiding these galaxies.
Exactly. And that's when he proposed the idea of Dunkel Materie, dark matter.
So he was the first to really put this idea out there.
He was. Of course,
Yeah.
back then it was a radical concept. People weren't sure what to make of it.
But then, a few decades later, another astronomer came along, Vera Rubin, and really solidified the evidence for dark matter.
That's right. Rubin was looking at individual galaxies this time, and she was measuring how fast the stars were orbiting around the center.
And what did she find?
Well, she found that the stars on the outer edges of galaxies were moving just as fast as the stars closer to the center.
Which is weird, right? Because you'd think the further out you get, the slower things should be moving.
Exactly. Like in our solar system, the planets further from the sun orbit more slowly.
Right. So this observation by Rubin really suggested that there was some invisible mass spread throughout these galaxies, influencing the motion of the stars.
And not just a little bit of mass either. We're talking about a lot, like 5 times more than the matter we can actually see.
That's huge. So it became clear that dark matter wasn't just some fluke, it was everywhere, shaping the structure of the entire universe.
And that's where we are today. We know it's out there, we know it's a big deal, but we still don't know what it is.
So what are the top contenders? What could this mysterious dark matter be made of?
Well, there are a lot of theories out there, some more mainstream than others. But let's start with one of the most popular candidates, WIMPs.
WIMPs. What are those?
It stands for Weakly Interacting Massive Particles.
Okay, that explains the acronym.
The idea is that these WIMPs are particles that don't interact much with normal matter, which is why we can't see or detect them easily.
So they're like ghost particles passing through everything.
Kind of, yeah. But they still have mass, and that's what gives them their gravitational pull.
So even though they're invisible, they're still shaping the universe around them.
Exactly. Now, another popular candidate is the axion.
Okay, axions, and what are those like?
Well, they're also hypothetical particles, but unlike WIMPs, they're incredibly light.
Like lighter than an electron light.
Way lighter, yeah.
Yeah.
But the idea is that there are so many of them that their combined mass could account for dark matter.
So it's like a quantity over quality thing.
Precisely.
Mm.
And there's another fascinating aspect to axions. In some scenarios, they're thought to behave more like waves than individual particles.
Waves of dark matter, that's kind of mind-blowing.
It is, right?
Yeah.
And then you have the idea of primordial black holes.
Okay, those sound intense.
They are. These are tiny black holes that could have formed in the very early universe, long before stars and galaxies even existed.
So they're like ancient relics from the Big Bang.
Exactly. And if there are enough of them, they could potentially explain the missing mass we attribute to dark matter.
So we've got these tiny particles, we've got waves, we've got ancient black holes. It's like a cosmic buffet of possibilities.
And that's just the tip of the iceberg. There are even more exotic theories out there, some involving extra dimensions and entirely new forces of nature.
Extra dimensions. Now that's getting into sci-fi territory.
I know, right? But it just goes to show how much we still don't know about dark matter and the universe in general.
Speaking of not knowing, what about those experiments at CERN? Didn't they try to find some of these dark matter particles?
They did. Back in 2022, CERN upgraded their detectors to specifically look for these hypothetical dark sector particles.
Oh, and did they find anything?
Unfortunately, no, they came up empty-handed.
So even with our most advanced technology, dark matter is still eluding us.
It is. It's like trying to catch a shadow.
Which makes you wonder if maybe we're approaching this whole thing the wrong way.
It's possible. Maybe we need to completely rethink our understanding of what dark matter is and how it interacts with the universe.
And that's where things get really interesting, because one of the sources we looked at for this episode presented a pretty wild scenario.
Oh yeah, this one's a doozy. It takes place in the year 2106 at the Argo Neutrino Array in Antarctica.
So we're fast forwarding a bit into the future.
We are. Now, according to this hypothetical scenario, scientists detect a very strange signal coming from a known dark matter hotspot.
What kind of signal?
It's a pattern of neutrinos, these tiny particles that barely interact with anything.
Neutrinos, okay.
But this wasn't just random noise. The signal had a specific mathematical structure, including what's called a recursive prime sequence.
So like a coded message.
Exactly. It was so precise and complex that it seemed like it had to be intentional.
Wow, so someone or something was sending us a message from within the dark matter.
That's the implication. Of course, this is all hypothetical, but it's a fascinating thought experiment.
So what did the message say?
Well, a top-secret international team was assembled to decode it, using advanced AI and all sorts of cutting-edge technology.
Sounds like something out of a spy movie.
It does, right. And after months of work, they finally cracked the code.
Drum roll, please.
The message was, "You are the shadows in our world."
Whoa, that's chilling.
It is, isn't it? And it completely flips the script on our understanding of the universe.
So instead of us looking for dark matter, maybe dark matter has been observing us all along.
Exactly. And maybe to them, we're this strange, invisible anomaly.
It's like that old saying, one man's trash is another man's treasure.
Only in this case, it's more like one universe's normal matter is another universe's dark matter.
That's heavy stuff. And this hypothetical scenario goes even further, right? It jumps ahead to the year 2130.
It does. By then, scientists have supposedly mapped out a good chunk of what they're calling the dark web.
The dark web, like the internet, but for dark matter.
Not quite. This dark web is basically the network of dark matter filaments that stretches across the universe.
So it's like the scaffolding that holds everything together.
Right. And what's really wild is that scientists in this scenario have figured out how to interact with these dark matter structures.
Interact. How?
By sending pulses of neutrinos towards dense clusters of dark matter.
And what happens?
They get a response. The neutrinos come back, but their patterns have been altered.
So it's like an echo, but a changed echo.
Exactly. And the changes aren't random. They're very specific and seem to correspond to the initial pulse.
So it's like the dark matter is processing the information and sending something back.
That's what it seems like. And that raises some huge questions.
Like, is this proof of some kind of intelligence within dark matter?
That's the big one. Are we actually communicating with something we don't understand?
Or are we just poking a sleeping giant, so to speak?
Well, that's another possibility. Maybe we're waking something up that we shouldn't be.
It's like a cosmic horror movie waiting to happen.
Maybe. But it could also be the greatest discovery in human history.
So it's both exciting and terrifying at the same time.
Absolutely. And that's the beauty of exploring these kinds of mysteries.
Because it forces us to confront the limits of our knowledge and to imagine possibilities we never even considered before.
Right. And even if these specific scenarios are hypothetical, they highlight a fundamental question. What if dark matter is more than just some inert stuff? What if it's a whole other realm, potentially with its own forms of intelligence and even life?
It's a mind-bending thought, but it's one we can't ignore.
Because if the darkness is truly observing us, as that message suggests, then who knows what the future holds?
It's a universe full of shadows, and we're only just beginning to understand what those shadows might contain.
And maybe the most important question isn't what dark matter is, but what it wants.
What it wants. Yeah, that's
Right?
a question we might not be ready to answer.
But it's one we need to keep asking.
Absolutely. So to all you listeners out there, keep looking up at the night sky. And remember, there's a lot more out there than meets the eye.
And maybe, just maybe, something out there is looking back.
Thanks for joining us on this deep dive into the mystery of dark matter.
Until next time.
Keep exploring the shadows.